Hey everyone, and welcome to The Explainer. Today we're going to cut straight through all that relentless hype surrounding artificial intelligence to get to the actual, on-the-ground reality of automation. We constantly hear about how AI is just going to flawlessly take over every single job, solve all our problems, and basically run the world on autopilot. But when we look at the hard data from the organizations that are actually trying to build and deploy these systems right now, well, a very different, deeply fascinating story emerges. The reality is far messier, way more complex, and honestly still heavily reliant on human beings.
Okay, let's dive into this. We've got a 5-stop multi-industry tour today. 1. The AI reality check. 2. Why physical AI struggles. 3. The blue-collar AI boom. 4. Professional liability and risk. And finally, 5. The 30% rule.
So starting off with Section 1, the AI reality check.
We really need to start with a massive reality check here. We have to challenge this pervasive narrative that AI is some unstoppable, flawless force that just works perfectly right out of the box. Because look, the numbers tell a completely different story. Check out this staggering statistic from Fitter Analytics. Right now, literally in the time it takes you to watch this explainer, nearly $1 million is being spent on AI globally, every single minute. And yet, despite that absolute mountain of investment, an incredible 85% of AI projects completely fail to deliver on their objectives for chief information officers. 85%! I mean, that means the vast majority of enterprise AI initiatives are completely missing the mark.
So the crucial point here is that this massive failure rate isn't usually because the AI itself is somehow broken. Actually, it's mostly due to human planning errors. A recent study by RAND interviewed data scientists and engineers, and they narrowed it down to 5 root causes. Often, stakeholders completely misidentify the actual problem, or they just lack the clean, sufficient data you absolutely need to train the model. Sometimes, and we see this a lot, there's just an obsession with playing with the newest, shiniest tech rather than, solving a real user need. It's classic shiny object syndrome. Combine that with inadequate IT infrastructure, or just trying to tackle a problem that is way too large and complex for AI to handle right now, and bam, you've got a perfect recipe for that 85% failure rate. At the end of the day, poor planning and totally unrealistic goals are the real culprits.
Moving on to Section 2, why physical AI struggles. Think about this. If deploying digital AI software is already struggling with an 85% failure rate in the nice, sterile, perfectly predictable environment of data servers, what on earth happens when we try to put AI into a physical robot to do actual physical work? Well, it gets exponentially harder. We have to contrast that perfectly controlled digital environment with the absolute unpredictable chaos of physical AI. Digital AI is great for chatbots, data entry, predictable screen-based stuff. But physical AI, as the robotics company Dexterity points out, it has to operate in a world that is infinitely variable. Imagine a robot trying to load a truck. The lighting fluctuates, boxes arrive crushed or in totally random sizes, pallets shift around in transit. To do this safely and at actual production speeds, these robots require a mind-blowing 99.9995% safety confidence level. They need incredibly complex, real-time reasoning for things like collision avoidance, force control, and anomaly detection, literally just to pick up a cardboard box without crushing it or accidentally hitting a human worker.
And this brings us to a really brilliant insight from Dexterity. The difficulty is the moat. You see, building one massive, monolithic AI model to handle all that physical chaos, it simply doesn't work. It leads to really impressive lab demos that just instantly fail the second you put them in a real, messy warehouse. Instead, successful physical AI requires what they call a compositional approach. Basically, teams of specialized AI agents working together, coordinated by a central orchestrator, where every conceivable failure mode has been anticipated. Honestly, overcoming those harsh, unpredictable realities of the physical world is exactly what separates viable, real-world industrial automation from just another failed startup.
Which leads us perfectly into Section 3, the blue-collar AI boom.
So, if physical AI is incredibly difficult to deploy, this really subverts a major expectation. We constantly hear that automation is coming for everyone's jobs, right? But when we look at the physical world, we actually find the unexpected winners of the AI revolution. Let me pose this question to you. Who actually builds all this AI infrastructure? Because every single breakthrough in digital AI sits on top of massive physical infrastructure that, well, certainly doesn't build itself. Data centers require literal miles of heavy conduit to be run. They require megawatts of power to be safely connected. And they need massive, complex industrial cooling systems running 24 hours a day, 7 days a week, just to keep the servers from melting down.
What this means is that electricians, HVAC technicians and pipe fitters are absolutely essential to AI's very existence. The demand for these trades is just exploding right now. And what's super fascinating here is that smart tradespeople aren't being replaced by AI, they're actively leaning in and using it. Smart technicians are using diagnostic apps that can read a complex system in minutes. They're using AI scheduling software to optimize their driving routes and AI-assisted estimating tools to win way more bids. They're literally using AI as a tool to increase their own daily efficiency and earnings.
And this brilliantly illustrates exactly where the smart money is going. Right now, demand for skilled trades workers in the AI era is growing roughly 3 times faster than the demand for desk jobs. 3 times! Major investors are pouring massive amounts of capital into trade training programs. And why wouldn't they? They've done the math. The jobs getting disrupted are the predictable, screen-based tasks like first draft analysis or basic coding. But a chatbot physically cannot crawl into a muddy crawl space under a house to fix a slab leak, and it sure can't pour a massive concrete foundation for a new server farm. When it comes to the physical world, human hands are entirely indispensable.
All right, Section 4, Professional Liability and Risk.
Now, let's pivot away from blue-collar physical labor for a second and look at white-collar professional services. Because here's the thing, even when AI is kept entirely on a screen, adopting it carries some immense legal and regulatory risks that companies are only just now waking up to. Have you heard the term AI washing? According to a recent legal analysis from the DWF Group, this is becoming a massive emerging risk for corporate directors and officers. AI washing happens when companies exaggerate or just straight up misrepresent their use of AI to seem way more advanced than they actually are. And regulators, they are not taking this lightly at all. Over in the US, the Securities and Exchange Commission has already brought enforcement actions against companies for making false statements about their AI tech. And in the UK, the Advertising Standards Authority is actively cracking down on misleading claims. You literally cannot just slap an AI-powered label on your business anymore without the hard legal backing to prove it.
Then, of course, there is the huge risk of AI hallucinations. This is when an AI system produces a result that looks highly credible, reads perfectly, sounds super confident, but is completely 100% fabricated. In a legal context, this is incredibly dangerous. In fact, due to the severe risk of these convincing fabrications, recent UK judicial guidance now explicitly bans judges from using large language models for any legal research or analysis. We've all seen the headlines of litigants using AI to draft documents and creating huge, embarrassing headaches in court. It just proves that AI simply cannot be trusted without a human expert meticulously verifying every single output.
Now, what's really fascinating when you look across different professions is how professional bodies are totally scrambling to regulate this tech. Look at how these different UK regulators are reacting right now. You've got accountants and auditors issuing strict ethics guidance on technology threats. Surveyors are launching entirely new global standards for responsible AI use and risk management. Architects, legal professionals, they're all releasing incredibly strict guidelines. What this essentially proves is that across every major profession, human oversight, critical thinking, and professional skepticism aren't just, best practices. They are legally required. You cannot blindly outsource your professional, legal duties to an algorithm.
Which brings us to our final stop, Section 5, the 30% rule. So, the big question is, how do we successfully balance the amazing efficiency of AI with these massive legal liabilities we just talked about? Well, the answer lies in a really practical framework. Let's move to and see how this builds into what's known as the 30% rule. The education provider Upgrad highlights this as a crucial industry guideline. Organizations should really aim to automate only about 30% of their tasks using AI, intentionally leaving the remaining 70% human management. It's absolutely not about finding a magic tool to do 100% of the work, it's about creating a balanced, sustainable adoption model. And this framework is absolutely essential for cutting through all the industry hype. By capping automation at 30%, a business inherently limits its operational risk and contains those dangerous AI hallucinations we talked about earlier. But most importantly, it preserves that critical human judgment. It maintains the professional skepticism that regulators are actively demanding. It ensures that there's always a real human being accountable for the final product, which is what keeps the business compliant, safe, and actually productive in the long run.
And that brings us to the ultimate million-dollar question perfectly posed by the legal experts at DWF Group.
As we push further and further into the future, when these AI systems inevitably become fully autonomous and their internal reasoning becomes completely opaque to us, who actually takes the blame? Will an AI eventually be given its own separate legal personality, or will human oversight always necessarily be the final safety net? Look, while this technology continues to advance at just a breakneck pace, the physical realities of our world, the heavy legal liabilities, and just the sheer messy complexity of real life guarantee one thing for sure. Human indispensability is not going away anytime soon. Thanks so much for joining me on this explainer. Keep asking the hard questions, and I'll see you all